Welcome to live stream number 3. We've had 2 live streams so far on the channel. This is the 3rd one. We had a little bit of a dodgy stream number 3 and we've had to repeat it, so this is that 3rd stream. In this stream we're going to look at how we load a model onto a 3D printer. We're going to use the model we've created in Fusion 360. We're going to load it up in Prusa Slicer and get it onto a printer. So without further ado, let's get over to Prusa Slicer. Oh, not Prusa Slicer. We'll go over to the Fusion 360 and get the file made. So we should be in Fusion 360. Here it is. So here's Fusion 360, and the file that we've got here is a one that we've made for our desktop tidy, which project we're doing, and this is one of the tool inserts that we're going to use to hold the tools. On this one here, I'm going to use it for holding a screwdriver, so I'm going to modify this before I save it as an STL, ready for printing. So let's get into modifying it. I'll first of all turn off the unrequired bodies, and this is the one we want to work on. I'm going to create a new sketch on here because I want to put a hole in here. I'm going to right click and create a sketch, and I need to turn one of these sketches on. I need to project the bottom sketch to the top. To do that, I'm going to press P for project, and it's asking me to select what I want to project from the drawing below, and I'm going to project this center here. I need to know where it is, and I'm going to press OK. Now I should be able to click on that on this drawing. Project, select, OK. That's better. So now we're going to draw a circle on here. And the diameter of this screwdriver I'm going to put in here is 5mm, I believe. But I'm just going to check it just to make sure. Oh, I think it's 6. Could be 6. Let's have a look. It is 6mm. So I'm going to make this 6.2. I'm going to make this. So I'm going to give it a dimension. I'm going to call that 6.2. I want it slightly bigger than that, bigger than 6. So I'm now going to extrude this, finish the sketch, and I see we have one person chat. Hello Genesis 100, nice to see you, and good to know I'm getting a bit of feedback. Thank you very much. So I hope you enjoy the rest of the stream. Let's see if we can get this item finished. So we're just going to extrude this into the body, like so. We're going to make it a cut because we want a hole in here to place the screwdriver into, and we're going to make it, we don't want to go down to the bottom, but we want it to go near the bottom. Let's say 21mm, shall we? Okay, 21, and that has to be a cut. It has to be -21. And we've now created a hole within that object there. So if I get rid of the other sketches, which is going to be this one and that one, and I get rid of that one as well, we now have the part which we want to 3D print. So we're now going to save this as a file, get it into Prusa Slicer and start it printing, because I want to try and get this printed during the stream. So to print an object from Fusion 360, we go to the file manager and we go to 3D print. You can 3D print directly to your slicer by clicking this button, but we're not going to do that. We want to save it as a file. So we select the object and we want to save it. You select the folder you want to save it into, and we're going to call this tool holder 2. It says it already exists because I've saved one very similar. It didn't have a hole in it though. This one's got a hole in it. So now we need to go over to Prusa Slicer, which is let me see where Prusa Slicer is. Prusa Slicer is, can you see that? No. Oh. So we've got a Prusa Slicer which is tool holder 2, which is this one, and hopefully we shall get that back on the screen. This one here, and here is the part, but it's the wrong part, so we'll delete the part. So in Prusa Slicer, this is the wrong item. We want to now import an STL, and the STL we saved, I'm sure it was tool holder 2. I was sure it was, but I could be wrong. I'm wrong. Let's try importing this one here, because I know this is the one I made earlier. There it is. So I'm now going to rotate this 190 degrees, like so. Don't want to print it like that. And before we can print it, we have to slice it. And let me see. I have something on my left hand side which is flashing, yes. And that is a 3D printer. You mean this light here? Well, if you mean that light there, Genesis, that is part of our printer. And I'll come to that in a short while. I've turned it on to get it going. If I just press this here, you'll probably see that will light up. And hopefully that's what's flashing and it's not something blowing up. Anyway, so we've got the object loaded in Prusa Slicer. We're going to check the print settings. And the print settings, we've got PLA, we're using a layer height of 0.2, infill 25%, and we've got a trim of 5mm. Now when I slice that, you will see what happens. I'm going to slice it, and here is what we get when it's sliced. That's what we're going to print. The green part of this object here is supports, and what that's doing is supporting the model while we print it, because where you get these overhangs, the printer won't be able to print in there without supports. So once we've got that, we're going to take the USB out of the printer. It's here. I can probably show you that printer if it's from here. So here's the printer we have, and the flashing light is probably the light that's on the side of here. USB goes in there, and this is the screen for the printer. So we're going to go back to the main. We're going to plug this in our computer, and we're going to save the file by clicking this icon here, and it'll ask me where to save it. I'm saving it to the USB drive, and I'm going to call it tool holder stream. I'm going to save it. Now that has saved that as a file on the USB. Sorry, I don't think you saw that, but all I've done, I clicked this icon here, and I've saved it to the file, and this one here will eject the USB from the computer. I can take the USB out of here, and we'll now go on to screen where the printer is. So we've now got this file on here. To get the file into the printer, we have to load it by USB. Put the USB inside, like so. This is one I printed earlier as a test, but that one has no hole in it, just a sample. So hopefully this one will print out good with a hole in it. We shall see. So on here, you probably can't see the screen on here, but on the screen here you have from a local computer, from a USB stick, which is there. And we're going to click on this one here, and you probably can't see the picture from there, but it says USB stream, so I'm going to click that one, and there's a bigger picture of it there. You can just about see the picture there, and I'm going to press print, and that we have an error. I'm going to print again. We have an error. So if we have an error, which we've got, we're going to reset it. This is why we do things live. Let's see if we can get it going. For some reason or other, this has come up with an error with that file. These things do happen every now and then. I hope my sound's good with my microphone being there, because I've got it really extended at the moment. So with this printer here, it's an Ender 2 Pro printer, and the standard printer only comes with a small display which you can't see there at the moment. This is a thing called Creality Sonic Pad, which has been added after, and you can control the printer a lot better with one of these, and it can go faster, but I've not tuned this one properly. So let's hope we can get this file loaded, because sometimes they can be a bit glitchy, especially with things like this. It's not designed properly, I guess. Works alright sometimes, but if it doesn't work, you just have to get on with it and make it work. So here we are, we're back in the screen. I'm going to try print, and we'll go from USB stick, and now it says USB not detected. So we take the USB out. Not very successful. Normally it's okay. And we're back in. So I'm going to pick that same one again, which is tool holder stream. There it is again. Will it print? No. The error we're getting is SD card print file name U2 holder is incorrect. So I'm going to download this one again. So I'm going to take this out of here, and I'm going to recopy. I'm going to go back over to the desktop. I'm going to save that file again. I'm going to export it, and I'm going to export it from the USB drive, and I'm going to call it something different. Tool holder new. Save that one. Then I'm going to eject the drive, and hopefully I should be able to take that out of the computer, which I'm going to do. I'm going to go back over to the printer. Did try this before, and it worked perfectly, and it normally does work perfectly, but that's what happens. So I'm going to try again. USB stick, and I call this new. This one, print, and there we have it. So that proves that nothing goes straight forward every single time you print with any sort of printer. You'll always get the little glitches and problems here and there. So the thing is, as long as you get around the problem, you're okay. And we've got around it and solved it. Not perfect. I'm not perfect. So as you know, if you've been following along the channel, we've been making a tool tidy, which is this device over here. And if I bring my camera down here for you, excuse the camera in the way, but we might be able to use this to give you some more info, a better picture of what's going on. we're making this tool tidy. Yeah. We made some of the trays which fit in here. There's the base. You can't. There's the base there with all the holes, which we're going to place these parts in. And we also have trays, and the trays come out like that. And I've made a few trays in this. And the good thing about it is that I can change these and make any different trays that I like. They're going to go in there. And for now, I'm not going to put all my stuff in there, my junk back in there, because it's going to be using some of that in a moment. So this is heating up now. A 3D printer consists of various parts, and what we're doing, we're basically converting a 1.75mm diameter filament like this into an object like that. So you might be asking, how do we get that to become that? Well, I'll show you. We have a printer. The printer has a roll of filament on the back here, which is here. It comes on a roll, and this roll here is about 2 kilos. There's plenty there to do the full print we want. What happens then? The filament enters the extruder, which is here, and that's on this. I'll get a better picture there. So the filament enters the extruder here, and these two wheels on here, one is a geared wheel and one is a bearing, and the gear wheel turns, which has got serrated teeth on it, and there's pressure holding the two gears together, and I'm going to show you exactly how that works on this one in a minute. We force the filament through the Bowden tube, which is this part here, and it goes down into a nozzle, which on this printer is one of these nozzles. This is the Mark 8 nozzle from a Creality 3D printer. So the first thing it will do, it'll heat this nozzle up to about 210 degrees for PLA, anywhere between 190 to 210. It's going to switch over to the camera. This might be a little bit easier. While that's printing away now, we should be able to, let me see if I can show you we can see that printing away while we're working on this camera. So I'll put that there, and let's get that in view, so we can keep an eye on the print while we're explaining some of how 3D printers work. So the first thing to notice is we have microphone, this here, which is an extruder. Now this extruder is a lot better than the extruder that's on our printer now, because this one is all made of anodized aluminium, and if you want any more detailed close-ups of this, let me know in the comments, and I will show you in detail. But it consists of a Bowden tube, which is this here, and the filament, which is here. I hope we're coming through loud and clear, and then the video quality is good. And I'm just going to have a nice cup of coffee. Hope you don't mind, but on my streams I'm having a drink. Keeps the consoles moving. So yeah, this here, tell you what I'm going to do. I'm going to move this camera here for now. No, I'm not. I'm going to stay with this one. So the filament goes into the extruder like so, and if I press here, you can see that what that's doing is making the gap between that roller and that roller wider. Thank you, Genesis. Nice to see somebody's watching and keeping an eye on things. So we squeeze that, it opens the two gears apart. This can then go straight through, like so. Once you get it in there a little bit, it's tight because the gears are gripped. If I energize this motor and turn the motor around, one of these gears will turn, and as it turns, it takes the filament into the printer. So that is now traveling down the tube. Very hard to see with that, but and to pull it out, we release that and pull it out, and you can vary the speed of this motor to depending on how fast you're printing. So that's the basic extruder, and what I might do is take this extruder off in another video and replace it for the extruder that's on the printer at the moment, because the printer one is plastic and it isn't very good, but this one's a better extruder. So that's a video for the future. Now on a 3D printer, once we've extruded the plastic to here, we then have to convert it into molten plastic to extrude it through a nozzle, which is this here. Now these nozzles are 0.4 millimeters, the standard one. There's a tiny hole in there, 0.4 millimeters. And if I can probably get this on here, I might be able to show you that. Let me have a look. I might be able to show you the close-up of that. Let me see. Or it might completely ruin the whole stream. I'm just going to try and see if I can get the microscope on here. I'm not going to do it now. But I have the microscope here, and I was hoping to show you that. One moment. Yes, we have here a microscope. So I hope you can see that. Here is a microscope, and I'm going to just show you what the nozzle looks like under a microscope. Here is a nozzle. There you have the hole that's in the middle of the nozzle. Yeah. So there is the nozzle. And that hole diameter is 0.4 millimeters. And there's the inside of the nozzle. That's where the filament goes in. It goes in there. And that's the inside of a 3D nozzle. It goes in at 1.75 and comes out at 0.4. So yep. So that's another little thing I have here if I need it. It's a microscope. Comes in very handy. Now it looks like we're printing okay on there. It's starting to build up. Just keeping an eye on it just in case something goes wrong, because things do go wrong as well. So we've seen the nozzle, very, very small hole. And in this printer here, we have this type of nozzle, which is a Mark 8 nozzle. There's two types of, not a nozzle, heating head, or extrusion head. Well, I get a Allen key, and I have an Allen key, so I'm prepared, you know, very prepared. Have a cup of tea. I'm not going to be rushing my streams. They're going to be pretty slow and easy. Now the printer filament, as Genesis has just asked, is 0.75 millimeters. There's two basic sizes. I think it's 3mm and 1.75. But 99% of the time you will find that people use the 1.75 millimeter diameter filament. And it's quite important that we get the filament correct size, because if the filament is too small, the distance between the teeth and the bearing, it won't grip the filament and it slips, and you get a grinding noise from the extruder. Now if I look at this, it says it's 1.7 millimeters. It should be 1.75. There's a bit of tolerance there, but normally it's pretty good. But if it's too small, it will slip. And also I could show you later on what the teeth put marks on the filament as it's being extruded. So if it's not been through the extruder, it's all smooth. If it's been through the extruder, you'll see the teeth marks where it's pushed the filament through. So yeah, thank you for that, Janice. Hope I've clarified that for you. So this type of nozzle here, we've got the Mark 8. It's on here, and I'll take the head off this one to show you. It's called a PTFE lined hot end. Now the PTFE lined hot end, as it suggests, tells you that the PTFE is right the way through from here, right the way down to there, right the way down to the nozzle. If I take this nozzle out of here, like that, there, I can push this right the way through here, and this is how it's set up in the printer. The PTFE goes right to the very end, right to the flush there, and then the nozzle goes right flush up to the PTFE, which means the PTFE is right on the hot end heater block, which is going to get up to 220 degrees maximum, because you don't want to go much higher with PTFE because it gives off volatile gases. So that's has the problem with these nozzles, these heater units, hot ends, the PTFE lined ones, is they have a temperature limit, and that's about 220 degrees. Any higher and you will have some problems, which you don't want. So that's the PTFE lined. And if you have a PTFE lined extruder, you will find that you will probably have to replace this Bowden tube probably after every 100 prints or something like that, because it will deteriorate as time goes by. So yeah, that's the PTFE lined hot end, Mark 8, and we'll show you that later. This one here is the hot end that I've converted most of my printers to, and it's called an all metal hot end. And the difference and advantage of an all metal hot end is the PTFE tube only goes down as far as here. It goes nowhere near where the temperature is about 160 to 220 degrees. This will only go down to there. Therefore, you can have this at a lot higher temperature. You can run this at something up to 300 degrees or 320 degrees, and this will stay cool. So that's the advantage of a all metal hot end. And I can show you that. I'll try and demonstrate it if I can. Our print's coming on. Let me just see if I can go to the printer. Can't see much there. What I'm going to do, I'm just going to turn get this a bit lower level. Let me see if I can get some reflection down here, but I don't know if I can. No, it's not going to be possible. Sorry about that, but I tried and we failed. I have had somebody give us some suggestions regarding cameras, and somebody just commented, which I'm going to do right now. They said that if I take the camera, and when I configure the video on it, I set it to a fixed focus. I'm not sure whether this is correct or not, but let's give it a go. So I'm going to, while I'm live streaming, it's probably not a good idea, but we shall see. I'm going to take this camera and I'm going to set the focus to manual, because he said what it was buzzing on the picture, and I think I can see it on here happening. So I'm going to put this camera into manual control, which it is. I'm going to manually focus it. So, and I'm just going to leave it in manual. And you shouldn't get the buzzing that happens on the picture. I'm not sure if I'm correct on that, but we'll see. That's now in manual focus. Sorry for the little delay there. Let's get back to where I was. So yeah, I was going on about the Mark 8 extruder, and I was going on to this is the E3D hot end, and this is a clone one. It's a Chinese copy, and they work, for me, they work just as good as any other normal one. So this is the heat break, and when that's screwed into there, the PTFE only goes into there 5mm. So in reality, that's what you have. And the heater block goes on there, as opposed to this one where the PTFE tube goes right into where the hot zone is. So you can see that they're perfectly okay for PLA and things, but and also this here is the same basically on both types of design. This is the heater block. Again, the heater block, we have a heater cartridge. This is a 40-watt cartridge, 24 volts, and it also has a PTC, which is a thermistor, and all that does is it, as the temperature rises, the resistance rises, and the electronics controls the output to the element, turning the power on and off, therefore heating it up. So when you set the temperature on the printer to something like 210, this thermistor is sensing the temperature, and the feedback is then putting power out to the element. I hope you understand that, but that's what it is. I can show you that as well. Let me show you let me take it apart. But I do like taking things apart, and I'm only doing this while we're waiting for that one to go. The table is becoming a bit of a mess, which is all right. I don't mind. I have a lot of Allen keys around, very handy. And in here we should have one which will fit this. When I get a tool tidy sorted out over there, these will all be accommodated in the correct places, but I can never quite find the right one. There we are. So the heater is held in by a clamp. You see there's a slit there, and when I slacken this screw, this slit is made wider and the heating element becomes loose. But there's also a a thermistor there. We need to take that out, so we need to undo this screw as well. So I'm going to do. Hope I can put this all back together. And when we take this apart, you'll see the two parts. So there is the heating element, and there is the bead thermistor. That's what's detecting the temperature. Now the only thing that's not right on this is this bead thermistor here has to be in contact with the metal. I would personally put some conductive heat compound in there, conductive paste. Then I would put that thermistor into that hole, because now if that was just in the hole and touching the air, it's measuring the air temperature in there, not the actual metal temperature. So if you have got one of these, take that out and make sure you put some heat sink compound in with the thermistor. And that goes back into there when we finish that. This is where we put it back together. To tighten that back in there. Hopefully we get it in the right place. With printers, you have to allow for the fact that you're going to have a lot of tinkering. If you're not a tinkerer, then printers probably aren't for you. Well, 3D printers aren't. There's always something to fix, play around with, modify, print. And people ask me, what can I print with a 3D printer? What use are they? Well, I printed this desk tidy, which I have on the side here. Now, if you want to go and buy one of them, you can't buy one like I've made it exactly to my specifications, the way I want it. It's impossible. I can draw an item up on Fusion 360 CAD program, or you can use something like Tinkercad, which is a online CAD software, very simple. You can use that and draw your own. Anybody can do it. If I can do it, anybody can do it. So we're going to put this back together now. We've got the heater block there. This is the heat break. I'll screw the heat break into there. When you put these together, if you have a 3D printer and you break one of these and you have to change it, take it all apart. When you're putting it back together, put some thermal paste on here before you screw it into there. Get it in as tight as you can with your hand, because you don't want to clamp that because it's a threaded part. And the printer's still looking good. Yeah, we're looking good there. And then once you've done that, you screw that into the heater block, like so. Now you want to leave a gap here, and then you screw your nozzle into the end, and standard is 0.4. Now when you screw the nozzle in, you have to make sure there's a gap between the nozzle and the edge facing of this nut part of the nozzle. The reason being is we want to tighten this up, and if there's no more space to tighten it, it ain't going to go anywhere. So if I just show you that, if I tighten this, that's the tightest it's going to go. This is loose. You'd have to turn that, which is turning the very, very weak point there, which is the heat break. You don't want to do that. You don't want to be turning this, you want to be turning that. So wind that in, turn that till you've got about 1 millimeter space, like that. And then you get what I would do, I would get a heat gun. You can connect this up to your 3D printer and heat it up to about 300 degrees. Or you can use the heat gun. And if you use the heat gun, you can heat the whole thing up to 300 on the end and tighten it. The reason you're doing that is, so if you heat it up to 300 degrees, everything is expanded. When you tighten it, when everything's expanded, as it contracts, it goes tighter. And that gives you a better job. So, and if you were then running at 200 degrees, it's never going to get to the stage where it's going to loosen off. So bear that in mind. So there's the two heat breaks. And also, sorry, not the heat breaks, the hot ends. And every hot end on the heatsink has a fan. On this one, which is the E3D hot end, it has this small fan here. It's a 30mm fan, and it just clips on like that, because you're heating this part up to 220 degrees, but you don't want this to be hot. You want this to be cool. So this fan blows air across the heat sink, keeping it cool while that stays hot. That's the theory anyway. And you have a thing called a melt zone, which is the place where it transitions from a solid plastic filament into a melted plastic ready for extrusion. And that melt zone should be just below the heat break or thereabouts. You don't want to creep, you get things called heat creep and things, but we'll not go into that on this video. This is just a dead simple video. I might do some videos later on explaining exactly in detail how one of these works. So that's the E3D, and that is the Creality Mark 8 PTEC relined. Which one would I have? I would always go for that one, and all my printers, as I say, I've got these ones fitted apart from that one, and I might change that to the same. I'm going to put them away. I'm going to put these away as well, off the table. Let's get them down here. Right, so we have the printer going. Have the bits here. Let's get rid of that one. That one I'm going to take apart at some stage. So according to our printer now, let's go to the printer for a moment. Well, let's go to our printer for a moment, which is here. And it's printing. It's looking good from here. It's a shame I can't show you any more detailed picture of it. I can't get to it. But it's looking good. According to the printer, it's got another 27 minutes, which is quite a while. But I'm going to hang out for 27 minutes and wait till the end, because I want to take that off there and test it in the actual holder. Now, earlier on today, I tested that print, and I printed another one. Which I have here somewhere. There's the one I printed. I haven't taken the brim off this side, but I'm going to do that now. The brim and the supports we're going to take off live, and hopefully it comes out okay. We'll do that in a moment. I like to try and keep things a bit tidy. So if you have any questions regarding any printer issues or printers or anything like that, let me know. Oh, by the way, this is the one I printed. These are some of the issues that you can have with 3D printers. And one of the issues is bed adhesion, which is probably very, very common. It is very common. The first layer of a printer is the most important. And if you don't get the first layer right, then the rest of the print is destined for failure at the end of the day. Take this one, for example. This print here, you can see how it's all deformed on one end, and it's deformed there as well. What happened here, I'll show you. If you can see that, I think you can see that one is completely flat, the one on the bottom, and the one on the top has curled up, both ends. The reason being is that the bed adhesion in the middle was very good, but on the side it wasn't, and it lifted. Because as you lay down each layer of plastic, it cools. And as it cools, it contracts. And as it contracts, it tends to pull up from the bed like that. And this one was unfortunate enough to fail. So I scrapped that one, and I basically did it again. And on this printer here, I cleaned the bed with isopropanol alcohol, because it was probably a little bit of grease on the bed. And following that, I got this print here, which is nice and flat, and it's square. And this is one of the trays for our tool tidy. Some are going to be blue, some are going to be yellow, some of them might be another colour. So this one here is destined for the bin. You can't do much with your old plastic, by the way. Once you've printed it and it's failed, you can heat it all up. I've heard of people taking all their waste plastic, heating it all up, and compressing it into a compact shape, such as a plate or plant pot or something like that. I've never tried it myself, but maybe a good idea. But I basically throw it away, because I don't do that many dodgy prints. Well, I do actually, quite a few dodgy prints. That's all part of the fun. And part of the fun of 3D printing is the challenge of of getting it perfect, if you can get it perfect, and finding the problem when you do have a problem, because believe me, there's a few problems that can happen. So here is a 3D print we did earlier, and it's basically the same as the one we're doing, but it has no hole in the end because we just created a hole on Fusion 360 to accommodate a screwdriver that I'm going to put in the tool tidy. So let's take this off and see how to remove it. For that, you're going to need a pair of snips. Very handy tool. If you've got a 3D printer, 90% of the time you will get these free in the printer, and they're only cheap. You can buy them on Amazon for a couple of quid, 2 or 3 quid for a pair, and then they're all right for what they do. And you're probably going to need one of these. Now this is a deburring tool, and a deburring tool is basically a curved knife, and that is flexed, it rotates on there. It's all floppy around, and the idea of that is, first of all, let's take the supports off here, which are, these supports are only to support the object while you're printing it, so they should peel off. And this might all go wrong, I don't know. We'll take that off, use your cutters, and just cut it off like so. And this is just to help it while it's printing. You don't need them, it's not part of the model. So we're going to cut them off. And this little bit of brim round here, we're going to peel that off as well. And it's come out not too bad actually. This is your deburring tool, and if you can see, there's a little lip of plastic on there. It's a tiny lip, and if you rub the deburring tool along there, it takes away the edge, and you basically have to do that with all the sides that need it. You'd probably find it's only on the bottom, the base, that's going to happen. And once you've done that, it'll be good. Now I've printed this in a certain orientation as well, for a reason, and I'll tell you for why in a moment. 3D printers print in layers. This one I printed in that orientation there. I could have printed it like that, and you might think, well, that's easier because it's flat on there. There'll be no supports needed going up here, and it should be a lot better, save a bit of plastic. But this surface here I want to be nice and flat and perfect. This is a surface that's on the bed of the printer, and the bed of the printer has a grained surface on this one. So when I'm printing that on there, I will have and I take it off, I'll have the surface of the bed pattern on here. So the reason I turned it sideways was so that when it was printing, it does its layers. The layers are formed, and these layers here will be absolutely perfect, which they look like they are. I would say that if I printed it. So let's just try it in the tool tidy. A bit tight. That is a bit tight. But if you see here, where the supports were, it's very rough. So I'm going to have to clean off a bit of that. And I'll probably have to use a knife on this occasion. So I'm just going to clean it up. You can use a bit of sandpaper or anything you have that's abrasive. A little file would do it. And it might be, if we can't get it to fit, I have to adjust the tolerance on these parts here. When you're printing things on 3D printers, if I print a hole at 20 millimeters and I print that at 20 millimeters diameter, if I try to put that in the hole, it might not fit. So I have to leave a distance of 0.2 millimeters, so smaller, so that will fit in the hole. But on these ones here, I want them to be really tight, so that when I put them into the base, they don't come out while I'm lifting the tools out from the hole. So I'm hoping that when I remove these little parts here, the bits that are sticking out, it will fit. Let's see, shall we? A little bit more on there. If not, I'll have to just make a little bit smaller than the drawing. But yeah, fits perfect. Yeah. That fits perfect, even if I do say so myself. I'll show you that in a minute. I can't show you now because the cameras are up there. I could do actually. Let me take that away. There's the part there. Look, here's the part. And this is the part I've just put in. This is the one I've tested. It's the part I've put in, which is just printed that. And this is a blank one. We're going to put holes in. The ones we're printing now will be designed specifically for where we want to put them. That will go into there. So nice and flush. And there'll be a hole in that, not where the screwdriver will go. So we'll wait for this next one to print. And that is quite tight. Don't want it loose. I want it a nice good fit, and that's, to me, perfect. And if you see this one here, this is going to be one of my designs as well. I've just poked 3 screwdrivers in there as a test, but rather than use one hole per screwdriver, this one will have 4 screwdrivers in one hole. Each one will be specific. So when we were saying before about 3D printers, what can they do and what use are they? Well, there it is. I can make this the way I want it. So let's see how we're getting on here. Hopefully, it's saying here 15 minutes and this print will be finished. When this print finishes, I'm going to wrap up the stream, and hopefully we will get there. Hopefully we're still sounding good and there's no issues. The streaming's working, and I hope I'm not boring you to death. But it's a hobby, and everybody likes hobbies. Well, various hobbies, whatever hobby is. Let's put this in the bin. So this one here is going to be 6mm, and this is the screwdriver I'm going to put in. Hopefully that will fit when I've made it. This is the first one to be used with a proper hole. And if you haven't already seen the tool tidy complete, I'm going to go here to Fusion 360 for a moment, and I'm just going to show you the whole tool tidy as it looks when it's finished. So if I start turning on these all these parts of the tool tidy, if you haven't seen this, if you can look for on the channel, you'll see other videos relating to this and other projects that we've done, so feel free to go and have a look at the other videos. The channel's pretty new at the moment, so they're probably not as professional as everybody else's, but they're the best I can do currently. I have a lot of data I want to put on here. I just need to get to a condition where I can present it in a more digestible way. So yes, these are the tool inserts, which each one is going to be designed differently. This will have a hole in it. This will be designed for pliers, for instance, and this one will be designed for other bits and pieces. And I'm just going to make them over time and then just show a completed model. So there's the trays, and each one of these trays we can move them out from here if we want. To show you, there's the trays that lift out like so, and this is leave that there for a minute. We can also lift out these if we want. Take them out for a minute. Fusion 360 is very nice to use. I like Fusion 360, and there you can see how it's going to look like when it's finished. And one thing, I printed these in yellow. Well, I printed some in yellow, and I ran out of filament. So I'm going to change it a bit. These two will be yellow, this will be yellow, and the rest of them will be blue, because I haven't any more yellow left currently. Or I might even make them multicolored. I haven't decided yet. And that's the thing, the beauty of it is you can change the size of these trays if you want, or make them any way you like. So yeah, that's what it will look like when it's finished, with these different holes and adapters there. I just thought I'd show you that. And that's where we are with it. Takes a bit of time, but it's worth it in the end. So I hope the video is looking good. We've got 10 minutes left on the print. It's printing okay. Doesn't look like we have any issues at all. So that's something to look forward to. By the way, I forgot to mention this here. This is the got to mention this, which is the pneumatic fitting. They're basically pneumatic fittings for airlines, and they use these to fix the tube into the extrusion head or the heater block. And they have you can push them one way like so into the unit. You should be able to. That's not the right one. Yeah, you will see on the printers you have these little tiny clips here. If I take this clip off for a moment, I'll just demonstrate how that works. These are like Festo fittings, pneumatic air fittings, and when you're putting these extruders together, you need to push the heat FE tube into the extruder, but you don't want it to come back out that way. So if I pull that, it won't go back. The reason being is there's some a little tiny barbs in there which stop it, make it only go in one direction, which is that way. So if we want to take that out of there, we push this ring in. There's a little black ring on here. We push that way, like so. And when we do that, we can pull it out. So we're pushing that, pulling that, and it comes out. If we don't push that black ring in, we can't get it. We push the black ring in, like so, and it comes out. But you don't want that to happen while you're printing or while your printer's running. So you have this little device here, which is a little clip. If I put that clip in there, if I clip that in there like so, it stops you pushing that way, so you can't, it won't come out. That's the idea anyway, and it works quite well. So that's what your little clip is for, if you get any of them in your 3D printers. Yeah, this printer we've got here, it's an Ender 2 Pro that we're printing with now. It's about 135 quid if you want to buy them online, thereabouts. It comes not with the clipper screen, the Creality Sonic Pad, but it comes with a standard screen, and they work just as good as anything else, to be honest, for printing. And if you're a beginner and you want to get into 3D printing, then that's probably a really good choice. It's cheap, You can get access to all the parts. You can change all the parts very easily, and yeah, it's well worth the money. It's one of the smallest printers I've got, apart from the I've got an up to printer, which is it's a smaller printer, but that's a different design to that one. But it has a handle on the top. I don't know whether you can see that, but it has also a camera on the top. How did that get there? If you look at my elsewhere on my site, you'll see a review of this Ulanzi light. It was recommended me by somebody who uses these, and it was a good investment. Yeah, they go through all the color ranges, and you can change the white balance from 0 to 9,000, I think. And the brightness goes up and down. It's controllable, chargeable via a USB, and you can just stand them by whatever you're doing, like so, and turn them on, like so. And you can change the color. I can give it a bit of a blue tint if I wanted. This is going off the subject a little, but hey, now I can change that to a red if I really want. Bit of if I cycle through the colours here, I can make the printer blue. So yeah, these are nice little devices, and I think they're about 16 quid each. Can't go wrong. So thank you to the person who suggested to get a couple of these. I think I got 3, so they're coming in handy. But anyway, back to where we were. I was just showing the printer here, and this printer has a handle on the top. You can actually lift this up and take it away, and it's removable. Very, very handy. Yeah, they're a nice little printer. When this print stops, if we've got time, I'll take the head off here so you can see what's in there. There's 6 minutes to go. Hope you're all enjoying the stream, and if you haven't had time to come along while it's live, you can watch it when it's when the stream's finished, of course. Click on the live streams on the channel page, and this one should be there. Should be there as soon as this one's finished. And if you want to like and subscribe, obviously it'd be much appreciated, and it helps me as I go forward, because I will get better. I will learn the software that I have to use to get on streaming on time and in the correct manner, and my presentation skills will improve. And I'm looking for advice on camera systems. I have this camera here, which is a camera here. See if I can get that one out. There's a camera here I have. It's a 920 Logitech, a Logitech 920 Pro, and it's supposed to be a really good sort of web camera with autofocus. But I found that the autofocus is a bit glitchy, probably because it's not designed to do what I'm doing with it. And I think you can get better cameras. Somebody said you can get a Sony ZV-1 or something like that, which is a nice camera to go up there with a good autofocus and a good macro capability. That's what I need here, with a zoom on it, so I don't have to have the camera in shot. I can have the camera up here and zoom down to an object on the table. That's what I want, but there's so many camera options out there. If you have any comments or suggestions on cameras I can use for the top camera, please let me know in the comments below. And if you have any comments on any other type of cameras for streaming, such as my main camera, which is this one here. At the moment I'm using a cheap camera. It's about 17 quid. It's called an AUKEY, an Orkey camera, and it's probably not the best camera, but it's doing a good job, I think. It's the same as this one here. This camera here is only a cheap web camera, which is it's doing the job. But I would like to improve them and make the quality a bit better. The lighting's not too bad. It's not perfect. So yeah, that's where we are. And I hope the sound's better. We've got this newer microphone which we've recently purchased on the channel, and I'm going to make some modifications to this. I want this extended so it goes out to here, so keep an eye out on the channel for that modification to happen. And in future videos I'm going to be putting this new extruder, which is an all metal anodized extruder with dual gears, onto this printer. But this one's got a basic single gear drive, and it's not the best, but this is perfect. So watch out for the next video for that happening. I'm also going to take this E3D nozzle and I'm going to put it onto this printer as well. So I'm going to make a modification for this so that I can print much more high temperature materials, and I can get rid of all this covering on here, so that if I'm demonstrating how a printer works or I'm printing something, you can see the printer better, print better. And that's where that's going to go. So keep an eye out on the channel for them two little modification projects which I'm going to do. They will happen. And let me see, we've got exactly 1 minute remaining on the print. So I'm going to go over to the top view. I want to set this up for an ending print, and hopefully we shall see it. Now you've got 1 minute left, and well, 1 minute 15 seconds. Count down till the end, and then we'll take it off. And then following that, a couple of minutes after that, we'll be ending the stream and putting this to bed till the next one. The next one will probably be next Saturday at 7 o'clock. And now I've got the knack of starting the stream properly, we should have a bit of a better experience. Now I know my sound's working okay. Yeah, I think it's going to improve a lot, and it's good to see that we have people in the chat. It's always helpful when people give you comments and let you know what's going on, because it's very difficult when you're doing a stream and there's issues that you can't see, and it always helps. So we have, it's saying it's 100% complete, so in a couple of seconds this will be stopping and the printer will be lifting up, going to its home position. This will come off the bed, and this bed here, it's a plastic flexible bed. This is made of like a PVC type material, which has a magnet on the underside of it. The bed is metal. This magnetic flexible bed sticks to the bed, and that's how it works. But when we take this off here, we will flex it, and it should just pop off. It's not the best of surfaces to print on, but it's a cheap printer. You can upgrade these to something better if you felt like it, or if you had the money to do it. And I think this one here has a slight problem with the timing, because according to the screen it's saying it's 100% completed. Estimated time remaining is saying it's 0, and it's on layer number 119, and there are 121 layers on this, so the actual timings are not 100% correct, but there's nothing I can really do about that, and I'm not going to worry about it. It's just one of those things. And now we're getting to the end. I'm hoping that's going to be really quick. We're now on layer 120. One more layer to go. We should have a big countdown with a fanfare at the end of it. But I don't think we're going to do that. I think I'm just going to get it off here, see if it's printed okay, and then I hope that gives you an idea of how a 3D printer can be very useful. We're making some objects, this tool tidy that we have here. We're making it specific for what we want. We're designing all the parts on Fusion 360 and printing them on various printers. Some of the parts I'm going to print on the FL Sun printer down there, because it's a lot quicker than this one. So there we have it. Hooray, the printer has finished. And the printer will stop, it'll go to home position, and all the heaters will turn off, and it will now be ready for another print. I'm going to take it off here. I'm going to take that off there. And to take these off here, let me see. So this is what you get. That's just magnetic on there. I'll lift that off like that. And then if I flex this, like so, it comes off like that. So what we have to do now, we have to clean this one up and see if it's got a hole in there and if we can use it as a screwdriver holder. So we'll take the support off this one, same as we did with the last one. And yeah, that looks pretty good. Not perfect, but this is not the best printer in the world. But it's good enough for these sort of things. So there we have that. And these supports here, it's put supports here. The reason being, we put a hole down the center and it needs to support the roof of that hole. So that's why it's put this on here. So I'm going to take that off there. And as you can see, we now have this with a hole in the middle. I need to clean that up. And also what's happened is there's a piece of plastic in here which they've left, which is a support we have to take out. So we're going to take that out of there. I would normally use a drill to go in there, put like a 6mm drill through it, but as I haven't got a drill with me, it's in the workshop, or should I say in a garage. Now this should fit in here. It doesn't, because it's got the needs drilling out. So for now, I'm going to drill that out with a screwdriver, because in there's a bit of support material, and I can't get it out with what I've got here. So let's put it into the where it's going to go. So this one is going to go in here. Cleaned it up a bit. Probably won't go in this one. Bit tight. Because the other one was the same. No, it won't go in the hole, that one, so I'm going to have to adjust the tolerance a little bit on here. I'm not going to keep you all waiting. I'm going to end the stream there. I shall fix this all up by clearing it out with a 6mm hole. I'll be rubbing that down with a proper small file and fitting it in there, and screwdriver will go in it. So I'm going to wrap the stream up there. Thank you for all the people who attended, and I hope if you're watching this in the future, there's something informative for you. And if you do like the video, please like and subscribe. It's always nice to see somebody a new subscription, and that somebody appreciates the work. And I will leave you for now. Have a really good day, and I'll catch you in the next one. Bye for now.